In this video, we are solving multi-step special right triangles. We need to find the missing side lengths and leave our answers as radicals in simplest form. So we're going to do problems 1 through 8, and we'll start with 1. So we're given two side lengths. We're given two angles and one side length. Our angles I will draw in black. So we have a 90-45, which means this is also a 45-degree angle. And we have, in this other triangle, we have a 90-45, and this is also a 45-degree angle. So now that we know this, we can start solving for our side lengths. Since it's a right isosceles triangle, we can see that if we go back up here to a previous video, which we did, that this is the way we're going to solve it, since there's two 45-degree angles and one 90-degree angle. So let's look at this first triangle. We'll do it in red. We'll call it 1. This is the first triangle. And our A, or our side lengths, is going to be this and this, because our biggest angle is right here. And our biggest angle is equal to B. And B is equal to A times the square root of 2. And we know this again from what we did up here. So now we need to find A. We need to find the side lengths because we were not given the side lengths. We could use B. I'll do this in black. We know that B is equal to A times the square root of 2. That's our formula. But for this triangle specifically, we're given 10. So we have this set equal to 10. And then from here, we can just find A. So what we're going to do is we'll get rid of this B because we don't need it. We're looking for A. And then we're going to divide both sides by the square root of 2. Once we do that, we're going to get A is equal to 10 times the 1 over square root of 2. So 10 over square root of 2. After we do this, we can multiply the numerator and denominator by square root of 2 over 2 to simplify this. Once we do this, we're going to get A is equal to 10 square root of 2 divided by 2. The reason why it's square root of 2 divided by 2 is because if we were to divide these two, we would just get 1. So it's okay if we do this. And then if we multiply the square root of something times the square root of that same something, the square root is going to disappear and we're just going to be left with that something. So in here, it's just going to give us 2. And then on the numerator, we're just multiplying 10 by the square root of 2. Once we do this, this 2 and this 10 can cancel out, and we're going to get 5 is square root of 2. So A is equal to 5 square root of 2. And we can write this in here. And that means this angle is also going to be 5 square root of 2. If we wanted to test this, we could by just plugging it back into this equation. We would have B is equal to A, which is 5 square root of 2, times the square root of 2, and that will give us 10. We could just do it real quickly. Let's say we're checking this. And we have B is equal to A square root of 2, and we know our A is equal to 5 square root of 2. So we're going to say B is equal to 5 square root of 2 times the square root of 2. Square root of 2 times the square root of 2 is going to give us 2. And then we have our 5 that we're just going to bring down here. 5 times 2 is equal to 10. And we know that B is equal to 10. So this is good. Next, we are going to find the length for our other triangle. This is going to be called triangle 2. So we know this is also a 45-45 90 triangle. So we're going to have our side length A, and we're going to have this side length as A. That means this side length, the long side length that we just found as A, is going to be B. So this side length, our hypotenuse, is going to be B. So that means B also equals 5 square root of 2, since it's the same side length. We can use this information to find A. We can say that our B is equal to 5 square root of 2, which we just found. And we know that B is also equal to A square root of 2 because of our special right triangle, or isosceles right triangle formula. So from here we can get rid of this B because we don't need it, and we just need to find A. What we can do is we can divide both sides by the square root of 2. Since there is a square root of 2 on both sides, they're just going to go away, and we're left with 5 is equal to A. So A is equal to 5 like this, and A is equal to 5 like this. We can test this again by plugging a into b. We know b is equal to a square root of 2. If we plug our a in, we're going to get 5 square root of 2, and we know that this is our hypotenuse. So this is the answer to this problem, and I think they're specifically asking us to find x. If they are, x is equal to 5. That is the work for that problem. Now we can go on to number 2. Basically the same thing. So for number 2, we should draw in all of our angles first. So this is also going to be 45 degrees, and this is going to also be 45 degrees, and this will give us a 45, 45, 90 triangle. Once we have this, we can start solving for our angles. So we are given 7 here. And since it's a 45, 45, 90 triangle, an isosceles right triangle, we know that both of these side lengths are a. And this side length is b, which is equal to a square root of 2. Well, if both of these equal to a, that means they both equal the same thing. So this side length also equals 7. And since our a is equal to 7, instead of just saying a square root of 2, we can just plug in our 7 here and say that our b is equal to 7 square root of 2. Now when we look at this second triangle, this bigger triangle, we know that this is our hypotenuse, so this is b. That means that this has to equal a, this side length right here has to equal a, and this side length right here has to equal a. So we can say that our b is equal to 7 square root of 2, and for our second triangle we can say that a is equal to 7 square root of 2. And since this side is also a, this is going to also equal to 7 square root of 2. And b we know to equal a square root of 2. So that means if our a is 7 square root of 2, we can just plug it in. We can say b is equal to 7 square root of 2, because this is our a, and this is being multiplied by the square root of 2. The 2 times square root of 2 is going to, or the square root of 2 times the square root of 2 is going to give us 2. We have our 7 that we have to bring down here too, and we have 7 times 2 is equal to b, or b is equal to 14, which is also equal to this x right here. So this is the answer for our x. Now we're going to move on to number 3. We see that we again have another 45, 45, 90 triangle. We actually have 44 45s until we get to 7 and 8. That's when we have our 30, 60, 90s. So we're going to solve another one of these. And actually, I think since we already solved 1 and 2, we'll skip 3 and 4 because they are pretty similar, and we're just going to move on to 7 and 8. 3, 4, 5, and 6 are all pretty similar to 1 and 2. But since we're given the hypotenuse on here, we'll just do 5, and then we'll skip 6 and go to 7 and 8. So we have 5 right here, and we're given side lengths. First thing we want to do is fill in everything we know, right? So we have our 45. This is going to also be 45, and this is 45. So we have a complete isosceles right triangle where we have 45, 45, 90. This we'll solve this in triangles. So this is triangle 1, and this bottom one is triangle 2. So for triangle 1, we have our hypotenuse. We have b is equal to 5 square root of 2. And we know that b from our formula is also equal to a square root of 2. So we can rewrite this as 5 square root of 2 is equal to a square root of 2. Since we have square root of 2's on both sides, they cancel out, and our a is just going to equal 5. We can test this if we wanted to by just plugging our a back into our equation, and we see that we get 5 square root of 2 for our b, which is what we wanted. So we'll say that this side is equal to 5, and this side is equal to 5. Now we need to find our a's for the second triangle. So we have a is equal to x, and we also have a is equal to blank because we don't know what it is yet, nor do we know what our x is. Well, this side that we just found to be a is equal to 5 is also b for the second triangle. So we can say that a is equal to 5, But for our second triangle, b is equal to 5. And from our formula, we also know b is equal to a square root of 2. To solve for a, get rid of this b. We'll divide both sides by the square root of 2 so that we get a by itself. So we're going to be left with 5 square root of 2 is equal to a. We can multiply our numerator and denominator by square root of 2. And if we do this, we're going to get 5 square root of 2 over 2. And that is equal to a. The reason why we're multiplying the top and bottom by square root of 2 over 2 is because we want to simplify this numerator or denominator. We want to simplify the denominator because a square root times the square root of the same thing is just equal to itself without the square root. Once we have this, we know our a values and we can just plug this in. And since a is equal to x right here, we can say that x is equal to 5 square root of 2, and we found our answer. If we wanted to, we can check this. We know b is equal to 5. And b is also equal to a square root of 2 by our formula. So we can just plug our a in, and our a is 5 square root of 2 divided by 2. So we have to have 5 equal to a, which is 5 square root of 2 over 2 times square root of 2, like this. Well, if we multiply these square root of 2's together, we're going to get a 2. And so these 2's cancel out, which will give us our 5. So 5 is equal to 5, therefore this passes our test, and this is the answer for x. For number 7, we have a 30, 60, 90 triangle. So we can start by writing in our angle here. We have a 30-degree angle, and we'll solve this for triangle 1, and this next triangle that's connected to it will be triangle 2. This is also going to be 30 degrees. So we can start with the side length that we're given, and that is 9. If we look at our formula, we have a 30, 60, 90 triangle on this side right here, and we can start writing these out. So we know from our formula that the hypotenuse, or the longest side, is equal to 2a. So this 9 is going to be equal to 2 times a. We know the side across from our smallest angle, which is this angle in this example, is going to be a. And the second largest side, which is 60 degrees, is going to be a times the square root of 3. This is the 30, 60, 90 triangle, and again we get this from our formula. After we have this, we can start solving our triangle. So we do have 9 is equal to 2a. We want to find a. A is going to be equal to 9 divided by 2. We're just dividing both sides by 2. So 9 being equal to, or a being equal to 9 over 2 means that we've found this angle. We have found a, and a is equal to 9 over 2. Lastly, we need to find this angle right here. For this angle, we have a square root of 3. Well, all we need to do is just plug in our a. So we're going to have 9 over 2 times the square root of 3. And if we wanted to, we could test this. We can say a, this is equal to a square root of 3. If we divide both sides by square root of 3, we get 9 over 2, which is equal to a, which is what we get here. And then if we plug it back into this part where we have 9 over 2, we're going to plug in our 9 over 2 for a. The 2's cancel out and we get 9 is equal to 9, so this is good. Our work checks out. Next, we have this smaller triangle. We have our 30 degrees, and across from it is x. X is our smallest side, so we're going to say a is equal to x. Our second smallest side is the 60 degrees, so we're going to say it is equal to a square root of 3. And in here for our hypotenuse, we, from our formula, know that this is going to be 2a. So now we can start plugging things in. We know that our 2a is on the same side length as our previous triangle's a square root of 3. And we know our previous triangle's side length is 9 over 2 square root of 3. So we can take this and set it equal to 2a. And if we take this and set it equal to 2a, we can divide both sides by 2. And then we're going to get 9 over 4 times square root of 3 is equal to a. So that means that this a right here is going to be this a right here. And after we do this, we could plug it into this equation right here. Well, we know that our a is equal to, or our a is equal to 9 over 4 square root of 3. So all we're going to do is just plug it into here. We are going to have 9 over 4 times the square root of 3 times the square root of 3. And if we do this, we know that our square root of 3's multiplied together is equal to 3. And we're going to have 9 times 3, which will give us 27 divided by 4. From here, if we wanted to check our work for a, well, a is equal to 9 over 4 square root of 3. And we know our largest side is equal to a, or times 2a. So if we plug in our a for 2a, and we can actually solve this out, we know that our longest side length is equal to 2a. And we know that our a is equal to 9 over 4 times square root of 3. So if we were to plug in our a for here, our 2a, it's going to be 2 times 9 over 4 times square root of 3. And so our 2's going to cancel out with this 4, and we get 9 over 2 times square root of 3, which is what our hypotenuse is. So our a works out. It looks good. Next thing that we're going to check is our a times square root of 3. And to do this, it's a little bit trickier. We know that our a square root of 3 is equal to 27 over 4. Well, to get a, we need to divide both sides by square root of 3. After we do this, we're going to cancel out these, and we get a is equal to 27 over 4 times square root of 3. Well, this is almost like our a. We're comparing it to our a up here. This is almost like our a. The main difference is that we combined our square roots together. So we're going to have to break apart this 27 if we want to compare it. This 27 is really equal to 9 times 3. And we can rewrite this as 9 times the square root of 3 times the square root of 3. And our square root of 3 cancels out, so we're left with 9 times square root of 3 over 4, which is equal to our a. So this checks out. So that means this side length is good and this side length is good. We only really wanted to find this side length right here, and this side length is just going to be a right here. So this is the work for number 7. Lastly, for number 8, we're given 2 more 30, 60, 90 triangles. However, the way that they're written can actually make it into a single triangle. So instead of looking at this as 2 different triangles, we're going to look at it as a single triangle like this. When we look at them individually, we know this side length is 30 degrees. And this side length is also going to be 30 degrees. And when we have 60 degrees plus 30 degrees, this is going to be a 90 degree angle. So instead of writing 30 degrees, we'll rewrite this as a 90 degree angle. And we'll still have a 30, 60, 90 triangle. So now we can solve this. We can bring out our formula for a 30, 60, 90 triangle. We know that the side across from our smallest angle is just going to be a. So that means x is equal to a. We know the second smallest side, which is 60 degrees, is going to be equal to a square root of 3. So this is going to be equal to a square root of 3. And lastly, looking at our formula one more time, we see that our largest side is going to be equal to 2a. So this side, which is our hypotenuse, is equal to 2a. So we can start solving these. We need to find a. This is the super easy way to solve the problem. Just find a and plug it into everything. So we have 5 is equal to a square root of 3. If we divide both sides by square root of 3, we're going to get that we're going to get that 5 over square root of 3 is equal to a. If we want to simplify this, we can rewrite this as 5 square root of 3 over 3, and that is equal to a. From here, we're just going to plug this in. So we've actually just found a. So this is going to be equal to x, so this is our answer for x. If we wanted to solve it in for here, we would just plug it in. We have 2 times 5 square root of 3 divided by 3 is going to give us 10 square root of 3 divided by 3. And that's the answer for that side length, and that is the work for this problem. So we have 8, 7, 5, 1, and 2 done, and those are some quick examples of how to find the missing side lengths given angles and another side length. Basically, we're given part of the triangle and we need to find the rest of it.